Beautiful.
Nice. All right, so I'll pass the mic back to Theresa just for a second. Again, happy to be here for an updated presentation to the OMSC. Always great to see everybody. Theresa is going to cover a little bit of our Metropolitan Transportation Planning, don't call it CFAC, updates, a little bit about contracting and the latest with the multimodal inventory. She will then pass the mic to me. I'll cover a little bit of the modeling pre-work, and this is something I was excited to talk to you about and get some feedback. It's a small modification to our TSP process, and then get into a little bit more about some of the work we're working with the multimodal data to develop a level traffic stress shapefiles for use in TSPs and other long-range planning efforts. Okay, Theresa.
All right. Well, good to be here again, and good to talk with you all. And I will have to duck out early for a doctor's appointment, but I'm sure Zachary will fill me in on all the good discussion. So this is just a quick reminder that the Metropolitan Transportation Planning, or CFAC implementation program, is pretty broad. And what you see on the screen is a range of the work that we have been undergoing over the last few years. And today we're really going to provide updates on TSPs, that multimodal inventory data, and like Zachary said, some guidance on modeling for TSPs. Next slide. So as a recap for the TSP transportation system plans that we're funding through the MTP program, because of budget constraints, we really had to focus on TSPs that were required for update by the end of 2029. So what we're looking at is those medium-sized cities outside of the Portland metro area. Jurisdictions within the Portland metro area don't have a set deadline to update a TSP or do a major update. And jurisdictions under 10K have availability of exemptions or delays in their TSP update. So we're really focusing the effort on a handful of cities. And we are requiring a cash match, and that the locals take on a good chunk of the community engagement work, as is becoming best practice as it is. But that reflects just the budget realities right now. We are preparing a lot of tools to support jurisdictions, whether or not we're funding them, how we're funding them. So we have we're calling it a CFAC TSP scope of work template. And my colleague Sarah is a good person to reach out to get access to that. We're providing it more to local jurisdictions, but it's kind of open for anyone at this point. Consultants have been working with it, so it's more public information now. We have published TSP guidelines and also the APM, which Zachary, I'm sure, keeps you updated on, and increasingly tools about this new Rule 830, which is a new expanded analysis for those capacity building projects. So if you look at our website and the link below, you'll see actually a new accordion that we'll be putting in any 830 resources that we develop, like how to tackle this, identifying the projects and that trigger 830, and then how to approach the analysis. Next slide. Here is a quick recap or visual of where we are at with the TSPs that we are funding. For this first group, we're so close to kickoff. It's been quite a while. We've been learning a lot. It's a new process, and it took a while, to get the scope dialed. But all of these jurisdictions are pretty close to kickoff, which we're excited about. And the second group here in green, they're all in some point in the negotiation process. And I think the central point mini RFP is still posted. I didn't check today what the status was. And then the grouping in yellow, we're in early conversations with them, starting to talk about, what are your 830 projects? Do we need to have regional conversations about them, whether or not they're priorities to keep in the TSP? Or as Zachary will talk about, we'll start approaching some of these modeling conversations. And so a couple of quick things that we're, emphasizing in these TSPs is, of course, a TSP is still a TSP. That's the phrase we're using. There are some unique things about a CFAC TSP, including the emphasis on multimodal for the gaps analysis, for performance standards, and for project prioritization. And as Zachary will say, a unique way that we're approaching these TSPs is starting that modeling conversation earlier, because it might inform that 830 conversation. And of course, that 830 work is new. So those are some of the key things that come to my mind as being unique and new in these TSPs. Next slide. All right, so shifting gears to the multimodal inventory. We are focused on what is required for a CFAC TSP, and what you see on screen is are those data sets. A lot of these we already have and you have used for TSPs, but when you look into the attributes, there's additional more robust requirements, right? And I think you've probably seen a version of this slide before, and it reflects the sources, typical sources for the data. Next slide. Here we have a little sample of what the Ecopia AI data looks like. Key thing to point out when you're looking at, I think that, let's see, the blue is the bike lanes, so it's center lines of bike lanes, and then the red would be center lines of sidewalks. So that's one area of difference that we're seeing with some local data sets where it might be an LRS format or the bike and ped facilities are appended to the road center line. So that's just one thing that we're how our standards might be different than some jurisdictions. But if you look, like the geometry is pretty good for the Ecopia data. Next slide. All right, so where are we at in producing this data? We are using a cohort model. So we have a pilot of about 6 jurisdictions, and they've all received their data. We learned a lot from those 6 jurisdictions, and we've integrated learnings into the 2nd and 3rd cohorts. Overall, we've delivered data to 12 jurisdictions. We're getting Springfield queued up as we speak to deliver that data, so that's exciting. And then we're in some phase of the processing for all the other jurisdictions. The process is very collaborative. We're building on the local data set first. So we have conversations about, accessing the authoritative data. We check in before we do anything with that data, and then check in again once we have some draft data where we've built onto that authoritative data set. And we have a closeout meeting where we also start planting seeds, gathering feedback about long-term potential for this data set and potential for collaboration. The quote-unquote raw Ecopia AI data is being delivered. So we've delivered it to all jurisdictions, that the 12 that have received the data so far. And from here forward, it'll just be part of the package of delivery. And the one data set that we got late from the vendor is the intersection point data, to be used for primarily LTS. And so that's forthcoming. Next slide. So quickly, a few learnings. With AI, we found early on that tree cover or tall buildings can obscure the identification of sidewalks, for example. Sidewalk segmentation was a little wonky, where it was segmented by width of the sidewalk. So if there were 5 blocks with the same width, it would all be one segment. So we've made some adjustments to those 2 layers across the board, and same with crossing distances, the crosswalk. Sometimes they would bleed into the actual sidewalk itself to make the crossing distance appear longer than it was. So that's something we're trying to correct across the board as well. We have had to integrate some estimates for a few of the required attributes in rule, and that sidewalk width and sidewalk condition are 2 primary ones. And so you see on screen a little bit of a description. So for sidewalk width AI, we do it by segment, and so that would include any bulb outs or areas where the sidewalk might shrink, or if there's a big shrub obscuring part of the sidewalk. So that's definitely planning level data. And then for the condition, we're using a proxy based on adjacent year built. If the jurisdiction has better data, we definitely take it. We have year built and then a rate of degradation for condition as a starting point. And definitely we have learned that local input is irreplaceable for things, especially like bike facility type, which AI cannot identify. So that's one thing we talk about during our meetings with our coordination meetings. Next slide. We're really trying to think about use cases and use cases beyond TSPs. And I'm open ears, and I'm sure Zachary is too, about how to use this data moving forward. Because the better we find use cases, the more likely we'll want to collaborate to maintain the data longer term, right? We'll see that value collectively in it. So TSPs, level of traffic stress, definitely use cases. But how do we take existing analysis one step farther? And these next 3 are ones that we're going to kind of build on as a project team and have in our final materials. But how do you take that modal mileage summary for each of the modes, walk, bike, road, vehicular, and then dig deeper? Do you have sidewalks on both sides of the streets? What's the coverage like in different areas of your community? We can also take a better look at walk and bike sheds from key destinations or transit stops. So again, taking analysis another step farther. And similarly with crash data, how can we overlay it with the new, more robust bike ped data to look at things differently? Next slide. All right, so quickly, I think, and then I'll hand it off in a minute to Zachary. This is our proposal for managing the data longer term, and it reflects kind of existing processes where locals would maintain the local data. And perhaps when you get as-built, so, go through a development process, the data can be incrementally updated for things like sidewalks. Note, some of these on the left-hand column are new for jurisdictions. So that's something we're having honest conversations with people about. Of these, do you think you can maintain them? What would that look like? Are there any that would have to be a lower priority for you? What we're hearing so far is that crossing data is new and valuable. Not to devalue any of the other ones, but that one is one that I'm really hearing kudos for. So as we move forward with the committee, we'll continue to talk about the priority data sets and the interval at which they should be updated at a regional and a statewide level. ODOT in the proposal would continue to maintain the data sets we have now and work with transit agencies on the GTFS data. And we would conflate and share the data on a ISRI web map for external viewing. So that's the proposal. And what we're looking at now is a working group, actually very similar to like OMSC for just shepherding the work forward. And so working group format and an MOU. So keeping it pretty peer-to-peer as we move forward with the next steps with the data. Next slide. All right, I think this is you, Zachary.
Hit that? Yeah. Here we go. Okay, people can hear me? Online? Everybody in the room can hear me. All right, great.
Yep.
Before I go, just any questions for Theresa from online or within the room here at ODOT?
I guess
Okay.
I was just thinking earlier, with the travel study, they're talking about, all the bike routing data of where people are actually riding bikes. And is that an interesting use case to apply it to now we're going to have these LTS networks? Are people choosing to ride there or not? Or where might there be the need for better facilities based on where people are choosing to ride that may not be ideal conditions? That's not a question, it's an observation.
Oh, yeah. No, I mean, I think that's certainly a potential application of the data. I mean, how we stick it all together and how it's used, I mean, that I think ends up being a little bit of the challenge, but it's certainly something that should be considered.
And the data, I apologize, my camera, I think it's on the fritz, but the data is not routable as it stands now. That is one thing that was not in the scope. We had kind of hoped we could get there, but we haven't. So just wanted to note that as well.
Okay, well, we'll maybe take some questions at the end if there's time. So getting
Great,
into
thank
some
you.
of,
And Zachary, I'll have to drop off, but Zachary, you can pass questions on to me, and you're on the committee, so you and you're pretty versed in the project.
okay, I'm definitely on the committee now.
You're on the the MISC.
I'm on the MISC, right?
Steering
All right.
committee.
Thank you, Theresa.
All right.
Oh.
See y'all later. Thanks.
Bye-bye. Okay, for transportation system planning modeling, and I'm always a little nervous about bringing it to this group of experienced modelers, not being one myself. Here's a little bit of the historical approaches I've discovered from talking to other folks. A lot of times when we're doing modeling, and again, it's travel demand modeling, we're looking really at future conditions, either for the no build or for the build set of projects. And that's usually done sort of in the middle of the TSP. It's 5 weeks or 8 weeks or 2 months, depending on what kind of thing, what size jurisdiction we're looking at. We're getting a lot of the land use already from existing conditions and from the future, from the comp plan, using a lot of times the RTP scenario. And then again, we're modeling that constrained transportation project list. And that's worked great. And we're not really suggesting any major changes to the overall process here. But there are some specific needs that we have with the new TPR, and this is what we're going to suggest. Some of the work from the modeling analysis guides came from this question about how to integrate these climate-friendly areas, which have to be approved prior to the beginning of the TSP, and they really sort of set this goal of having 30% of housing, or having the CFAs themselves be zoned to accommodate up to 30% of housing by the horizon year. There's some changes to the requirements for traffic analysis per 060. There's some new parking rules that are related to it. And as Theresa had mentioned, and you've heard this many times, one of the key components of the modeling as it related to transportation system plans, if there is a Rule 830 project on the constrained or unconstrained list, will have to complete a Rule 160 VMT analysis. The horizon year then needs to be household-based VMT per capita has to be less than and no greater than existing year. So with all those factors together, how can we make sure that the modeling component of TSPs works as efficiently as possible given these new requirements? After a number of discussions, and again, for this OMSC group, none of this should be a surprise, is that, of course, transportation projects carry trips, but they don't generate trips in the same way that land use, demographics, and employment allocation do. And these ultimately are where the trips are going to and coming from, and making sure we have those scenarios dialed in prior to getting into the long aspect of modeling from a TSP, and then therefore the impact on VMT is really critical. One of the things we learned from the Milwaukee case study, which is on our website that Theresa linked earlier, and we had a great collaboration with Metro, is that even though Metro regularly, as part of their RTP process, sends out requests to local jurisdictions to have them update some of their land use, they don't necessarily get a lot of feedback, and that's a lot of response on that. And there's lots of different reasons for that. It's not really bad or good. But one of the things we found with the Milwaukee case study is that the addition of a couple of multifamily buildings within the Milwaukee, sort of the city center area, were not in the travel demand model. Adding those buildings in there and updating the information did indicate that for a jurisdiction that was already expected to reduce VMT per capita by, I don't remember the numbers, by about 3%, adding those buildings added an extra 0.5% or even maybe a full percent. And there were some other modifications related to that. And those are important factors, especially when we look at some of the data we've gotten preliminarily without CFAC compliant TSPs that really show most of the jurisdictions in Oregon are within just a handful of percent of a growth in VMT or even sort of a decrease in VMT per capita. So we're looking to try and say, let's be proactive and get on top of that. And the first step for doing that is making sure our existing conditions model, it's not that they're not accurate. They are accurate, and they are accurate for what they've been used for. But now can we dial in a little bit extra precision for this particular new use where that extra precision can be of value. And we want to do that early because we know the land use application and allocation and projects do take a long time. As Theresa said, there is a irreplaceability of local input. We know in addition to modelers, local staff are also fairly burdened with not a lot of time to do a lot of work, and getting a chance to work with them, with local staff, local city staff or county staff, to integrate a housing needs analysis, to build a 20-year employment forecast rather than a 10-year is really absolutely critical. But this all takes time. And doing it in that before mentioned 6-week or 2-month period really is going to put a lot of pressure on getting it right the first time, and we're suggesting a slightly different approach. The first part of that approach is really a temporal shift. We're not talking about moving trips to the off-peak hour. We're talking about moving the modeling work throughout the TSP process. We're really hoping that the burden on staff is not going to increase the number of hours. We're just going to take those 60 hours or 80 hours or whatever the number of hours, and instead of having them compressed in a tight time frame in the middle of the project, really try and spread it out so we have opportunities to really build in the communication and collaboration through some meetings for really checking and confirming things on the ground, being able to review some of these all important studies that really help provide that level of detail. And again, I'm talking about what goes into the model at that TSE level. But we're going to spread it out over that 12-month time period, roughly. Again, I don't know exactly the time, but the idea is we're going to try and get it started even before the TSP gets underway for ODOT and for TPOW to work with modelers and local staff. And then once the consultant comes on board as part of the TSP, get a chance to sort of incorporate their expertise in that. From a resourcing standpoint, myself and Katie Brown, who the two of us are on the TPOW team here, are going to be doing a lot of this work and a lot of the legwork as part of our regular jobs. Right, Chris? Yes.
Sure.
Right.
Right.
And of course, for the models at TPOW, sorry, I knew you might not have been ready for that one. But also from TPOW, obviously, we're maintaining and operating some of the models for 5 areas around the state. And we've already seen this with Medford, where Alex and Jin have been able to produce some of the base year models, send it to the city of Medford, and we're going to meet with them in about a week or so to sort of really walk through it. But here's the ask for everybody else here. And I don't see Kelly, but hopefully you're online. But certainly with Metro and SCATS, we don't have your models. And we're going to hope that we can work with you to try and narrow down the requests of the information for an upcoming Salem TSP or an upcoming City of Milwaukee TSP, for that input to get delivered to the locals, and then for us to collaborate to really try and take a look at existing conditions, first of all, and then come up with some of these future scenarios to make sure we're all meeting the needs of the TPR from a land use point of view, with the thought that if we can eliminate and we can improve on some of the precision of some of the aspects of the model, again, keeping with all the regular rules about population and the rest of that, that for jurisdictions that might have an 830 project, the preliminary data seems to say that they're going to increase their VMT by 2% by the future year. How can we work right off the bat to take a big whack and try and do that? That's the hope. I will say we haven't tested this yet. This process, it's going to take a little time to work out the kinks. We want to start early so we can make sure we get on the right page and really start seeing what we can do to help out. Turning to the 830 specifically, there are a lot of questions about what involves sort of the modeling. Again, for projects that come up, and we've really only seen the I-5 Boone Bridge so far. We're using that as a good example to do future projects in different jurisdictions, to work with modelers, whether it's TPOW or travel demand modelers, on the area of influence. For the Boone Bridge, we did a 5-county area. We might look at a single county for a smaller jurisdiction. SWIM is going to be our tool for measuring induced demand. Again, that's not a pass-fail. That's just sort of one more piece of information for the local jurisdiction to make a decision on authorization. And I think there are some ways, certainly to minimize some of the staff time with SWIM, with Alex and the modeling team here, to combine projects by geography, facility type, so like projects that are all arterials or multi-phase projects. And there may be a way that we could try and develop some induced demand for like a really small one-off project that might not show up in SWIM. That's sort of to be determined. The next step, if you remember from the modeling analysis guideline, we did start on something called the climate-friendly area integration checklist, which is really effectively some of the stuff that we were on talking about. This was a nice to have. The consultant did a really good job of getting us a long way there through a number of subsequent conversations. Katie and I, and really Katie, are really taking a deep look at it, and we're working on developing a draft, and that's something we want to share with the OMSC, and I think even to a certain extent the APM users group as well, in order to have a better understanding of what checklist, what things we need to look at in order to do some of this work. We'll include an updated flow chart to sort of help guide us the process. Again, TSPs are still TSPs. We're just integrating and bringing in a couple of sub-steps in the overall process. And again, that overall importance of that QA/QC for existing conditions is really critical in terms of dialing in that precision. Again, trying to get models to do things that they really haven't been expected to do in the future. And now we're asked to sort of perform that. And I think we hope to have a draft sometime by the end of Q2. I think that's all I had on the TSP modeling. I'm going to cover the LTS stuff quickly so we don't run out of time, but then we'll come back maybe for questions. So LTS on the level of traffic stress, again, building on our multimodal inventory data, this is important for our performance measures in section 910 and 915. This was a contingency task that we authorized about a month ago. DKS is taking up the bulk of the work. Really what we're trying to do is take the information that we've gotten from our local jurisdictions from the multimodal inventory and running a script in Python with NGIS to do the LTS calculations. Again, this is nothing extraordinary in this sense. It's been done before at a lower level, but now we're really trying to do all the different segments that are part of our project. I learned something new, which I did find out my daughter in engineering school already knows about the MVP, the minimum viable product, which is a software product. I didn't know I know about MVP, but not about this particular one. And, but yes, that ultimately is our goal here, is to something that is really going to be able to take new data, bring it in and output the shapefiles. What we did find is that the bike layer, and we'll do this also for the pedestrian level of traffic stress, is really set up, and we're really just adding one data table for that. We're doing with Albany from Theresa's list. You see that's an upcoming soon to start TSP, so that's going to be great. We'll run a second test on Beaverton, a bigger jurisdiction, maybe slightly different type of line work. And then hopefully we'll then be able to batch process it. So at the end of this, we'll have more than just a minimum viable product. We'll have really a base level of LTS. Again, segment LTS specifically, bikes and PEDs for all the jurisdictions we're collecting data for, which I think is 40 something plus. Again, with any data set, it's not going to be 100% perfect. I don't have an exact number, but hopefully we're going to be in the high 80s or 90s. And again, it'll be up to the locals as part of that long-term data management to really dial in corrections for what it produced, as well as changes when facilities get upgraded. Also, we're trying to get DKS is trying to do this work in a way that the programming code works for the segments, and then we're then going to port it over once we have the rest of the intersection and intersection approach data. And once we have all of that together, then that question about routability, question that Cody asked earlier about integrating it into the overall plans with some of the routes we might have from the household survey, that's when we can get some of that magic to hopefully happen. Again, it's a Python toolbox script. Now I'm a little bit off my skis here on the programming stuff, but basically we've replicated the tables in the APM in if-then statements to basically figure out what LTS is. And in some ways, you're almost starting with the worst LTS, and then as you get attributes that indicate a better LTS, you're able to sort of move through the chart, the flow chart that way. What you see on screen, again, is sort of a programming code aspect. I'm sure these slides will be shared. Apologize for the small little program. For pedestrians, it's a little bit more complicated, maybe a little bit less. It's the case where the code doesn't necessarily follow along the way a human would within the manual, but effectively it'll produce the same sort of results. And then ultimately you'll have a shapefile output. Again, we don't need to create a new shapefile. This will just be appended as an additional attribute column to the bicycle layer and of course, or the pedestrian layer. But we basically should get segments from scores from 1 to 4. I looked at an initial run a couple of weeks ago. The stuff that looked like 4s resulted in 4s. Things that look like 1 off-street pass look like 1s. I think 2s and 3s are sometimes where it gets a little bit sticky. There's also a number of attributes like ADT. We don't have ADT for your local street, but we do have its functional class, and we can make some assumptions about that. So there's a few things that are going to build into it. For those that are familiar with the work that we have for the VMT, calculation for the models, we're also going to produce a document that follows along with that, a little bit of a stepwise process to really be able to allow people to check the steps and ask and make maybe slightly different assumptions. Again, with the idea of batch processing, it should be a push and go to update, every 6 months or every year, however often the data will get updated. A couple other comments here, just on a few lessons learned. Spatial data with roadway was needed, but we had already known that the data from the roadway segment was coming in as part of the multimodal, so that worked out really nice. Again, we're making assumptions for the stuff we don't know. There's some things we don't have information about, parking spaces or blockages. Again, those are some assumptions. We're finding that those are really, I won't say edge cases, but they're only small, single-digit percent of the overall LTS. And again, when we're thinking about how they're really applied, they're less. We don't need to be perfect in order to be very good. And then another example of that is also with the buffer and the idea that making an assumption of an 8-foot when we have a buffer to include that value. Finally, and this is my last slide, and we can get to quick questions. I know I'm a little bit over time per usual. We're going to continue testing out our segment analysis. Hope to have that done by the end of Q2. We have a lot to do the next 3 months. Once we have the intersection approach data from the multimodal project, we're going to work on the programming stuff. So hopefully we won't make too many mistakes with that. And there are people that know how to do that in TPAL or else in our data section. And then effectively this minimum viable product is a shapefile that will be part of the toolbox for local TSPs. So, and what else we got here? Oh, this might be an old slide. Skip that. That was an old slide. Metro is always helpful for QA/QC though. All right. Thanks for that long monologue. Any questions from the room or from online? I was not monitoring the chat.